notation, f's negative 1x, we call it the inverse of f of x. So we don't call it negative 1, we call it an inverse. Where have we seen that before?
In like
Sine, cosine, tan, right? When you're trying to get rid of a sine, you do inverse sine. When you want to get rid of a tan, you do inverse tan. We're just going to look at graphically, what does that look like? What does it mean when you take the inverse? You're thinking reciprocal. You're mixing reciprocal and inverse.
Oh, I am.
The inverse of reflection represents the reflection over the diagonal line y equal to x. Why, of course it does. Represents the reflection over the diagonal line y equals x. So we have done vertical, we have done horizontal reflections. This is called diagonal reflections. Diagonal reflections. First thing I'm going to do is draw this line y equals x. It's a line, so it's a linear function. Y equals mx plus b. What's the b value? What's the b value? 0, because there isn't one. What's the slope? 1 over. So up 1 over 1, up 1 over 1, up 1 over 1. And I'm actually going to just draw this with a dotted line, not a real line, because it's not really part of our graph. It's just a reflection line. And just for the first example, we'll do the inverse of a linear function. So I'm just going to pick any kind of line. I'm making this up. Let's put a y-intercept at 5. And let's put an x-intercept at negative 1. Again, totally making it up. And so diagonal reflection means the points that are above the line are going to go below the line, and the points that are below the line are going to come up above that line. It's a diagonal reflection. And so what's going to happen to this y-intercept at 5 is it's going to become an x-intercept at 5. And the x-intercept at negative 1 is going to become a y-intercept at negative 1. There's your first graph of an inverse. It's a diagonal reflection. Now this is hard for me to show you, but tactile people. Put your ruler right on that diagonal line. And I want you to actually fold your page right where the ruler is. Okay, so I just put my ruler right on that diagonal line, the reflection line, and then I folded my page to make a nice crisp. And you can tell if you have the correct diagonal reflection is if you fold it, does the red go onto the black? So you kind of have to look in between, which is a little bit hard for me to show you. But does the red go right onto the black? Okay, that's a really good trick on the exam to know if you have the correct reflection, is they should go right on top of each other. Which part? So when you flip it over, does the red meet the black? Are they kissing each other? Are they right on top of each other? That means you have the correct diagonal reflection.
Yes, they should repel it.
Oh. To sketch the graph of the inverse, switch the coordinates. I forgot a C in there. Switch the coordinates. Yep, of every point. Switch the coordinates of every point. xy goes to yx. That's it. That's an inverse. We just switched the coordinates. Sketch the inverse of the following function. State the domain and range. Who wants to be on domain and range duty?
I got it.
You sure?
Yeah.
Do we need a backup just in case?
I think Sean should be back.
Okay, Sean will be the backup. What kind of function?
Quadratic.
Quadratic, what's the three pieces of information you need to draw a quadratic?
1, 3, 5. The width.
The vertex is
5.
offer of 2, 5. Confirm. Nobody confirming. No, very good. The width?
1, 3, 5.
Confirm. Direction?
Down.
How do you know?
Negative in front of it.
And because that negative is a vertical reflection, and vertical reflection flips it down. Okay, so let's draw the parabola. 2, 5. Over 1, down 1. Over 1, down 3. Over 1, down 5. Question is asked for the inverse. You don't have to draw that reflection line. Some people like it because it's visual. Some people hate it because it's in the way and they're not visual people. Totally up to you. You can draw it. Just don't do it as a solid line because it's not actually part of the graph. It doesn't have to be in red. It can be in pencil. So if you like it, great. If you don't like it, that's fine as well. All we're going to do is take our coordinates and flip them. If you wanted to be a coordinate person, I'll do that over here with you. If you're not a coordinate person, wait for me. I'm just going to pick these 5 points from left to right. So the first point we had was 0, 1. The next point we had was 1, 4. The third point, which is our vertex, 2, 5. The fourth point, and the last point. Thank you, Simon, and no one else, because nobody else helped there. 0, 1 is going to go to?
1, 0.
1, 4 becomes?
4, 1.
2, 5 becomes? He's totally trying to outdo you. Do you see that?
3.
And? If you're just a coordinate person, you can come over here and do the same thing. So in our head, 0, 1 is going to become 1, 0. 1, 4 becomes 4, 1. 2, 5 becomes 5, 2. 3, 4 becomes 4, 3. And 4, 1 becomes 1, 4. Yeah, absolutely. Yeah, you can just actually do the vertex and count. You just have to remember to count sideways, not count up and down. Again, if you want to check it, that's why I like to draw this line, and I just flip it over, and I go, does it end up back where it should be? Does it end up on each other? Domain and range. So remember last year when I was like, parabolas only go up or down, except next year when I lie to you, that's when they can go side to side. So if it's an inverse of a regular parabola, they go left and right. I heard very quietly, x is less than or equal to 5. Confirm. What's the other notation in case somebody likes it better? Negative infinity to 5. Range? Not on the right-hand side, though, right? There's nothing past this point right here.
Oh, I see. Okay.
Sorry, somebody started to say the range. And I entered. Kind of. Y-E-R. Or negative infinity to infinity. What do we have waiting for us? Ooh, a square root graph. Turn to someone and describe the shape of a square root graph. That was fun. Some people described it with emotion. Some people described it with a sound. Some people described it with words. That was awesome. Yeah, whoosh, whatever.
Yeah, whoosh.
Okay, we got some transformations before we can actually do our inverse. So base graph of the square root. What does it look like? Where are the coordinates for the base graph?
It's got 0, 0, 1, 1.
Ooh, he's on fire.
4, 2.
And, nice. What kind of transformations do we got going on here? Ooh, a VT6 down. An HT3 left. Confirm. Would this graph be in red?
Yes. No? Oh, you still got,
We still got the inverse to do, right? Because that's what the question asked for. So not red yet, not till we're doing the inverse. So we're just counting 1, 2, 3, and 6 down. Bless you. This is where you grab red pen because we're going to do the inverse, and I'm just going to go point by point. The first point is -3, -6. Flip it. -6, -3. The next coordinate's -2, -5. -5, -2. Then I have 1, -4. That, oh yeah, we're good there. And 6, -3. Match your arrows, so if one end has an arrow, the matching end's going to have an arrow. If it's got a stopping point, it's got a stopping point. How could you check this on the exam if you wanted to? Flip it, make sure they kiss each other. Again, you don't have to have that reflection line. It's completely up to you if you want to draw it. Write down the domain and range of our last graph.
X is greater or equal to -6. Y is greater or equal to -3.
There's the offers. I hear kind of confirmation. I love how he's gripping his can of Coke. Like, there's some serious Coke drinking going on there. Questions so far? Show me your thumbs, getting it, kind of getting it, not getting it. Put them really high. I can't see when they're in front of you. Awesome. Second type of question is find the equation of the inverse. So this doesn't want you to graph it. It actually wants you to give the equation of the graph. Method first or example first? I knew you'd say that. Step 1, replace f of x for y. Because we know they mean the exact same thing, so we take f of x out, put y in its place. Step 2, switch x and y. Switch x and y. Step 3, isolate y. Step 4, replace y for the inverse of f of x. So we're just putting in the right notation at the end. That's it. So I'm going to take f of x out, put in y, again, because we know they're the exact same thing. Step 2, I'm going to physically switch x and y. I'm not changing any of the numbers. I'm not changing any of the negatives. I'm just physically picking them up and swapping places. So I get x equals 2y minus 1. It is not for an inverse. Anything else we can't switch, but inverses we can. Now it's, oh, sorry, Andrew, question?
How would we input that into our graphing calculator?
To do the inverse notation,
Yeah.
you should have a little -1 notation. It's a second function, something that I can't remember off the top of my head. We want to get the y by itself, so how do I get rid of a -1? How do I get rid of a coefficient of 2? And the last step is necessary because right now I have two different things defined as y, and mathematically I can't say y is two different things. I'm going to say, well, this really isn't y, it's the inverse of f of x. So inverse notation comes in, everything else on the right-hand side stays the same.
Can you just write x plus 1 over 2?
Yes, it's just I'm so used to doing y equals mx plus b that I like them separate in my head. But yes, there's nothing wrong with putting it all over 2. Because it's linear, I think I just want them separate in my head. But yes, you can definitely put it all over 2. Here's a third type of question they might ask you is determine algebraically if the following functions are inverses. And then they're going to verify your answer graphically. So we're really doing it two ways. Are these inverses yes or no algebraically? Are they inverses yes and no graphically? Okay, what do you want to do?
Something.
Yes.
Y.
With each other?
Yeah, you can't really. Yeah. You do like x minus 2 equal to y squared plus 1.
So you'd like to find the inverse of this one?
Yeah.
Yes. And then you would like to find the inverse of this one? And then if they match the originals, we're good. So I'm going to split the page because I'm left-brained, I have to. So I'm just going to do the two algebraic inverses. If they match the original equations, we're good to go. What the heck is this over here after my parabola? It's a domain. So let's just ignore it for now, and we'll come back to it at the end. Just pretend it's not there. How do we find the inverse of an equation? Replace y for f of x. Done. Switch x and y. So x comes to the left, y goes to the right. Yes, now what? Okay, how do we get rid of a +1? -1. What's the opposite of squaring? Except, there's a little rule from last year. Plus or minus, remember that? +2. And I'm going to stick it in front. Are these the same? Are they exactly the same?
No, like minus 2. Like
Yeah, this is okay. So I'm not so sure what's happening here. Well, let's do this guy and see what happens, then maybe we can talk about the domain. Same process, flip x and y.
so you literally only do y and x, not like the whole.
Correct. The only thing that move are x and y. Nothing else moves. No numbers, no negatives, no roots, nothing. Ooh, +1. Are these the same thing? Are they exactly the same thing?
Yeah. No.
No. Why are they not exactly the same thing? Because
the domain is the original.
of this guy. So let's talk about him. What is this meaning when x is less than or equal to 2? Well, describe this parabola to me. What does it look like?
The letter U.
Letter U, does it go up or does it go down? It goes up. Well, what is this going to mean if x is only the values that are less than 2? It stops at the vertex. This is going to be half of a parabola. So we're going to draw it in a second, but just a little quick sketch. This is only half of a parabola, which if I turn half of a parabola, what do I get? The square root graph. That's where it comes from. A square root graph is half of a parabola. So are these going to be exactly the same? No, because what's the inverse here? What do we end up getting here? A full parabola. Are these the same thing graphically? No. Well, let's compare here. This we know is our swoosh, and we know it's been moved over a little bit. What's this plus and minus stuff? Well, that's a positive swoosh, and the negative will be a vertical reflection. It's the other half of the swoosh. So are these inverses of each other? No. It's a parabola moved on its side. That's where it comes from. What if this domain restriction hadn't been there? Then it would be inverses. It's just because they've restricted this original. Let's prove it graphically. We're just going to graph both of these. So we'll start with the parabola. Vertex. 2, 1, I heard somebody offer. Direction. Up, width. Now what about this domain stuff? So how do I show x is less than or equal to 2? Yeah, anything past 2 to the right of 2 isn't going to exist. So the left half is going to stay. What happens to the right half? Bye-bye. There's a parabola with a domain restriction. They've restricted us to any value less than 2. Okay, square root graph. What's the base graph? Yep, describe it to me. 1, 1. 0, 0. 4, 2. 9, 3. And if you didn't believe me before, if we count, we're over 1, up 1. And then up 1 over 3, up 1 over 5. That's the connection to the parabola. Now we just need to do our transformations here. What are our transformations? And perfect. So we're going to take each point. We're going to count. 1 to the right and 2 up. Now, if you're not a visual person, you're still like, I can't tell if these are inverses of each other. What can you do? Put your right through the middle of quadrant 1 and 3. If we flip, what's going to happen? They don't. They don't touch. What does that mean? Not inverses.
Oh.
How could we change this so that they were inverses? Well, it's not necessarily the domain, because then we would have the other half of the parabola, and we don't down here. What would we need to do to this to make it the inverse of this guy? Instead of being the left half of the original, we would need the right half. So how could we change this?
Reflection.
Yeah, how could we change this to be the right half of the parabola? X is greater than or equal to 2 would have given it for this one. Yes, sir.
Shouldn't the thing have started as over 1 up 2 instead of over 2 up 1 like you drew?
Oh, crap. Yeah.
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 I don't want to say anything, so I'm scared.
Now, like, where are my other left brains? Like, you completely understand what I'm feeling right now. Like, I just want to redo it, the whole thing, because it's just nasty.
I just feel like
Hello, that's twice in one day you've come to visit.
That's stocking status.
I think that's 3. 3 in one day, I
Three?
think.
Okay.
Yeah. Yeah, nice. Nice. Ooh.
Since you're working the table,
Yeah.
advanced
Oh,
ticket sales.
nice. Smart.
Yeah, it only took me 7 years to figure out, but I got there.
Okay.
But just give me a stamp on the back.
Why?
They're not graphic cards, so
Okay.
you have a lot of these floating around.
Understood.
That's why.
Understood.
Just that option is in there for the last 4 years, and these. It happens.
Okay. Gotcha.
So here's for that.
This will be a great grade 9 project.
And then this also is one of